Okay, a little bit more complicated. Now, in this case, you've got the function and it's in already factored form. So in some ways that makes it easy, but it does create a couple of tricky places. It's like when we do the horizontal asymptote, remember we're supposed to look at the degree of the numerator over the degree of the denominator. So a shortcut is you could multiply the thing out completely if you wanted. And you could say, oh, look, the degree of the denominator is 2, the degree of the numerator is 2, so the degrees are equal. So the horizontal asymptote is the lead coefficients 1 over 1. Or the shortcut would be you'd say, okay, well, I've got an x times an x. I don't have to multiply out the whole thing. So x times x is x squared, and that's going to be 1x times 1x. So that's also x squared. So, okay, x squared over x squared, 1 over 1. Whatever the case, the horizontal asymptote turns out to be 1. The vertical asymptotes, you're already in factored form. So you can just say, oh, yeah, I just find the zeros of the denominator. So I've got -6 and 2. So here we go again. We can go ahead and graph those vertical asymptotes. And we can graph the horizontal asymptote. So, the horizontal asymptote's not at 0 anymore. I got a bad feeling. Horizontal asymptote's not at 0 anymore. Slant asymptote, no, it's got a horizontal, therefore no slant. X-intercepts, zeros of the numerator. So you had x minus 5, so x is equal to 5. You had x plus 3, so x is equal to -3. So our x-intercepts, 5, 0, because for your x-intercept, the y value is 0, -3, 0. So I got 5, 0, and that's like way the heck out here. Yeah, no, +5, sorry. +5, 0, and then -3, 0. Uh-oh, this is already looking weird. I don't like this. Okay, good old y-intercept is when you set the, put 0 in for all the x's. So you could do it either way. You could put 0 in here. So 0 minus 5. I know you're thinking, why are you taking all these steps? All right, I'm sorry, because it's just the video. I know we can take a lot of shortcuts on this. So that would be -15 over -12. So the y-intercept is 0, what would that be? 5/4? 0, 5/4. So the critical thing is 0, 5/4. You're above the asymptote, aren't you? You are above the asymptote. Now and I hadn't said this yet, but I'll say this a lot in class. The point of intersection is the biggest pain on these problems. Point of intersection is going to be the biggest hassle. So we have to set the original function. In this case, I would set the simplified. So we're doing the POI now. These are the biggest pains on these problems. So I'm going to set the function in standard form equal to my point of intersection. My point of intersection was 1. And now we got to solve this. So we have to cross multiply. But you said not to. I said if it's an inequality, equalities, it's okay to cross multiply. We love cross multiplying equalities. Oh no, what a horrible problem to solve. Hey, look, check it out. The x squares immediately cancel. That makes this problem easy now. So let's see what happens if I solve this. So what am I going to get? Add 2x to both sides, add 12 to both sides. So x is equal to -1/2. Uh-oh. I'm sad now. X is equal to -1/2. X is equal to -1/2. -1/2 is about right there. What's the corresponding y value? Well, the y value at the horizontal asymptote is always 1. The y value is always 1. Now you could, if you wanted to, you could take that -1/2 and plug in -1/2, and you solve it, you'll get 1. But I'm saying the big shortcut is every y value on the horizontal asymptote is a 1. So I don't need to go back and do that. I just determined that the point of intersection was at -0.5, 1. So they'd be about right there, which gives us a huge clue about the shape of the graph. Because, these two guys have to connect, and then these two have to connect. So we have to connect these points right here. Then the question is, oh no, is it going to curve back down? You already know it doesn't curve back down. There's no other points of intersection. It can't cross the asymptote, and there's no other x-intercepts. So it cannot turn back down. There's no x-intercept. There's no point of intersection. So I know that the only place for this curve to go is up like this. And then somebody says, well, what's happening over here? Can it turn and come back up? Well, I know that there's no other points of intersection. I just determined the one point of intersection, so I know it can't cross the asymptote again, so it does not turn and come back up. So the only place for it to go is to turn and come back down. And somebody says, well, what about the accuracy? I know I was just a terrible slob. This probably should have curved more over here. I'm not going to grade how perfect the graph is. I'm not going to grade how perfect it is. Oh, holes in the graph. We already had it factored. So we already had it factored. Nobody canceled. Nobody canceled, so there's no hole in the graph. Okay. Yeah, I probably should have been more accurate because this thing curves over here before it comes down, but we're just doing slob graphs. Then somebody says, okay, well, what's happening over here? Well, does it curve up? Can it curve on up like this? No, because there's no other points of intersection. So the only place for this graph to go is over here and to come back down. And then somebody says, well, can it curve and go on up? Or can it cross the asymptote and then run along the asymptote? You say, no, it cannot cross the asymptote because there's no other, you've got one point of intersection. There are no other points of intersection. So the only thing for the curve to do is to run alongside the asymptote like that. Oh no, what's happening out here? Well, see, now we definitely need to do a test point. So if I come out here and did something like, what would that be? -8, -7. So if I did -7, if x is -7, so if I plug -7 in there, if I plug -7 in there, that would be -12 times 4 over -1 times -9. So -48 over 9, which is who knows what, 5 2/7. Point being, it's negative. That was wrong. It's not supposed to be negative. It's supposed to be positive. What did I do wrong here? -7. Oh, that'd be -4. So it is positive. It's supposed to be positive. I knew it was supposed to be positive because I knew it was supposed to be up here. So that's 5 point something. So it's up here somewhere. So that's basically telling you, oh, the entire graph is above the axis. So the entire graph is above the axis. So it must curve like this. And you know there's no other points of intersection. So kind of like the previous problem, as I go from the domain, as I go from left to right, I have to exclude the vertical asymptotes. Then with the horizontal, then with the range, this would be a fair problem. You're saying, but it's got that horizontal asymptote. Yeah, but we crossed the horizontal asymptote right here. So this middle part right here actually goes just by itself. It goes from -infinity to +infinity all by itself. Okay. So definitely getting a little bit more complicated.